Good morning, everyone. My name is David Macleman. I'm the Research and Development Manager with Scottish and Southern Energy Power Distribution. I'm responsible for a portfolio of transmission and distribution R&D projects. So we've got quite a number, which I'll start to talk about. And today we're going to focus on the Orkney Smart Grid. Now, bearing in mind the first time I spoke about the Orkney Smart Grid was a number of years ago, and that first talk was an hour and 15 minutes. We now have run several one-day workshops on the Orkney Smart Grid, and we could run more one-day workshops on the Orkney Smart Grid. So in 15 minutes, this is not going to much be an insight, it's more a high-level fly past. And there's a slide at the end to send in questions, and there's a lot more information on our website as well, so I hope you'll take the time to follow this up. So just as has already been mentioned earlier on today, to be clear that I'm representing the WARS business, the Scottish and Southern Energy Power Distribution. We are part of the SSE Group, which is the FTSE company here in the UK. Market capitalisation of SSE is over 15 billion. And then within that context, the WARS business is a significant part of the business with assets over 3 billion. And the difference between ourselves and the rest of the DNOs in the UK is that we are part of this vertically integrated group. So we have to be very careful as a regulated business to observe those boundaries, but it's useful to operate within the context of a group which is the UK's largest non-nuclear renewable generator, substantial gas business, telecoms business, and UK's largest street lighting contractor. We're also very proud within SSE to be a living wage employer and recently awarded the Fair Tax Award, Fair Tax Mark. So I've mentioned about a portfolio of projects. There's a whole host of them there. They're in the context of this low carbon network fund, and some of them are also innovation funding incentive projects. And Ofgem were quite foresighted back in 2005 that they recognised that the regulatory regime was forcing us, all the DNOs, to be quite short term, and we weren't really investing in research and development projects. So the innovation funding incentive led on to the Low Carbon Network Fund, now led on to the Network Innovation Allowance and the Network Innovation Competition. And this is all to tackle the sort of issues we've been starting to talk about this morning. So today we're talking specifically about the Orkney Smart Grid. I'll touch on the Orkney Energy Storage Park and some of the results from that. We're also going to talk a little bit about domestic demand side management. And this is very much within this context of connecting more renewables into the network. So this is the distribution network within the context of the transmission network that we've heard about already this morning. And the challenge is very much to meet these renewable energy targets, get the faster connections I've just been challenged on a few minutes ago, and make sure that we're not a barrier to low carbon technologies. The other thing is that the definition of smart grid. Okay, we quite blithely got it up here as Orkney Smart Grid, and there's probably as many definitions of smart grid as there are people in this room, or maybe a few more. So we'll just leave it that it's an undefined term which is about getting more visibility in the network, as has been said already. But for us, a lot of the driver is about this integration of low carbon technologies. So that's very much what we're going to focus on here. So talk a little bit about the drivers behind the smart grid, some of the work that's built up to where we are today, project development, where we're going, and you're going to have difficulty seeing the detail of the results on this presentation, but a little bit of detail and then just some signposting for where we're going to go. So there's no great surprise here that the driver is to facilitate the increase in renewable generation. The situation in Orkney, it's a bit ironic that it's a fantastic renewable resource, but there's a lot of pressure on us because basically we'd reached the capacity of the local network. And that capacity was taken under traditional planning terms, which basically means we have to be able to accept all the renewable output at times of minimum demand. And this is to avoid overstressing the network, causing problems for customers that are connected, and potentially burning the wires down ultimately. So the cost of upgrading the Orkney network was identified as being around about £30 million for a distribution connection, or in the order of 100 million for a transmission connection. So this was a significant barrier to renewable generators, and also there was the time involved in environmental impact assessments and the infrastructure upgrades. So the pressure was on us to find an answer to this, and this is something which hadn't been done before. So we had to, this work started back in 2004 with some funding that came from the DTI, and we were working with the University of Strathclyde, and this led to us taking use of another facility from Ofgem to create one of the UK's first registered power zones. So in 2006, November 2006, we did the first closed loop trials on the A&M, and then in November 2009 we connected the first generation. So active network management is a term which has been used previously within the industry, but within this context, active network management, we specifically defined it as being a real-time deterministic control of distributed energy resources to keep the local network within its constraints. So there's a number of key things within that definition, and you'll see the Orkney network there with the mainland and some of the outer line islands have been divided up into zones. So we have to manage it within the zones to go back to this point I was making earlier of making sure that we don't overheat the wires, we don't cause problems for other customers connected to it. So what we have is real-time controllers at these zone boundaries going into originally a programmable logic controller, which is now migrated to a server system just very recently. And that provides this real-time deterministic signals to the generators. So we're very proud of this project that we've done, and it's to the credit of Scottish Power and WPD and UKPN that they've picked up on this technology. The work we were doing at the University of Strathclyde, we reached the limits to what we could do with the university. So then that led to the creation of a spin-out company called Smart Grid Solutions. And SGS have expanded across to North America just last year and successfully exporting the Scottish technology. Where we are at the moment with this smart grid is we've connected just over 20 megawatts of generation, and we're contracted to connect over 25. So within the overall national scheme of things, it's not a big deal, but for Orkney, it is a very big deal. And the reason I'm majoring on this is this provides an insight to a model which could be rolled out in other parts of the country, Scotland and nationwide. So the way it works is this real-time deterministic control is quite key from the generator's point of view. So if we just connected up all the generation, as I said, we'd have loads of problems. So what we've had to do is we've been able to accept them onto the network when the network capacity is there and there's demand to be able to use the generation. And then at times when the demand is lower and there's an issue starting to appear on the network, then we pick that up using real-time monitors and we turn the generator to turn down. If they don't turn down, if they don't obey the signal, then we've got to knock them off to protect the network and to protect other customers that are connected there. And if they turn down their output and the demand picks up, then or other generation drops off because the whole system is operated together, then they'll get a reset and they're allowed to ramp up their output again. So this was an innovative commercial contract as well, which meant that the generators were given information from us as to what level of constraint they would experience, but more importantly, what units they would get onto the network and what money they would make from that to ensure that they're a viable investment. And Triodos Bank and the co-op at the time looked very closely at this technology and provided project financing for the project. Technically, there's a lot more detail beneath this. As I say, there's loads and loads of information on the website. But basically, we've got the connections to the generators on the right-hand side of the screen. They'll go back through, we manage the communications, and then goes into the power flow engine. And this takes the measurement points and makes the decisions that are then back out to the generators. So in concept, it's relatively simple and straightforward. but in practice it's exceedingly complex, and we're making further improvements to the system based on the years of operational experience that we have now. So as you'll have seen from the previous slide, there's a number of times that we're sending a signal to the generator to say, you know, sorry, you can't get onto network at the moment, you've got to reduce your output. That's not good news from the generator's point of view. So we filled up this active network management arrangement as well. So there's more pressure on us to get more generation onto the network, reduce the constraints that these generators are experiencing. So there's a couple of things that we were looking at, and one of them is energy storage technology. Now, we were one of the first DNOs in the UK to get involved in energy storage. We started a project with a zinc bromide battery up at Nairn in the northeast of Scotland a few years ago. And that was a great R&D project because we managed to break it quite comprehensively. But we learnt a lot from that, and that provided a foundation of knowledge that we've built on. We've now got street level batteries down in Slough. We've got a 1 megawatt battery, which is one of Europe's largest, up in Shetland. And we learnt a lot from the technology, but commercially it was a very difficult proposition for us to accept. So what we've tried was a different commercial operation, which is a bit like a regional council advanced factory unit. We thought, right, we'll create a site, we'll provide an electricity connection, in this case 11,000 volts, and we'll provide a commercial signal. We'll create a market using some of this funding from Ofgem just to run a trial here, and see if we can send a price signal to encourage somebody to set up an energy storage unit where we'd like it to be on Orkney. So we went through a fairly rigorous tender process, and it ended up that it was Mitsubishi Heavy Industries and the SSE Generation in a joint venture that were successful. So they've installed a 2 megawatt, 500 kilowatt unit, which is a lithium ion battery. And you can see the unit up there on the left. This is a real battery. It's been up and running and operating for some time now. And this is a little bit of a snapshot on how we were trying to create this market mechanism. And basically, we were paying an availability payment to encourage them to be there in the first place, and then we were paying a usage payment when we were actually using the battery to accept this excess renewables. So it's a little bit of an artificial market situation, but what we really wanted to do was to try and see if the energy storage provider could tap into the multiple revenue streams that were available to a third party. They're not available to us as a wires business within the regulated industry, but a third party could set this up, and they could take advantage of the short-term operational reserve market, look at the transmission usage system charge, the distribution usage system charge, capacity payments, and arbitrage, basically buy low, sell high. And so this was within a slightly artificial situation up in Orkney. So we had to do some analysis, run some scenarios to understand that, and we had to build the business case, but we realised it was artificial, so we had to look at a generic case down in England, and then we projected that forward into the new CFD market and the capacity payments to try and understand if this was a viable proposition. There's a lot of detail here which you can look at afterwards, but basically the analysis of the information and the price signals that we were getting from the energy provider meant that there was still a shortfall no matter how we looked at this. So we had to consider the payback over different periods of time. We had to consider the sort of asset that was likely to be used in this context, and projecting it to the forward, this is where we ended up. So you can see right up on going back, you'll see there's some big gaps in those previous slides, but jumping ahead to the end story, there's a small gap there of around about £6,600 a year, which was the revenue shortfall. So this was as far as we could take the business case. So it's there for third parties to pick up on the work that we've done, to look at the new CFD market, to look at the capacity payments. There's an awful lot of money being spent on research and development in energy storage. So we can expect that the technology can improve, we can expect that the cost will come down. So just because we've not been able to get the sums to add up just exactly the way we'd like them in this project doesn't mean that this is not going to be viable. So just thinking back to where we were as a traditional DNO, operating separately with generation, networks in the business in the middle there, and then the demand down at the bottom on the left-hand side. So what we've done on the Orkney Smart Grid is we've now linked and working in this real-time manner with the generators. And that's got us so far, and it's not the complete answer. And what we've done up in Shetland with our Northern Isles New Energy Solutions project is we've linked into the demand side as well. And this was a project that started a few years ago, and we were quite keen to work with National Grid as a transmission system operator level, because we saw that the situation in Orkney, where the conventional power station was going to have to be replaced, and there was a pressure on the Shetland system to try and accept more renewables. So it's even more ironic than Orkney that Shetland's got this fantastic renewable energy resource, but because of the actual physics as to how you operate an electricity system, we were limiting the renewable input to around about 8% of the total requirement. And we wanted to try and push that as hard as we could. So the issues that are going to come up in the future, and it was touched on earlier by Julian about stability and people concerned about security of supply, is one of the key things is about frequency response. And also we reminded the ferry bridge incident and what happens when you lose large conventional plant or a transmission line trips out. So generation has to pick up that loss of generation capacity, or you can drop off the demand. So what we were trying to do was try and tie a number of these things together. So we were looking at putting in thermal energy storage into customers' properties. So basically these are the systems that have been used on the continent that Stephen was identifying a little while ago there, the thermal stores. And we worked with Dimplex to develop storage heaters that actually stored heat. And these operate at a core temperature up to 750 degrees centigrade and will store heat for several days. So again, using the low carbon network funding support, we put in a trial in 6 houses, and we received very good stakeholder feedback from these householders, and we are now rolling that out to 750 homes and hopefully up to about 1,000 in Shetland. Again, working with smarter grid solutions to make this frequency responsive within this overall context of trying to get more renewables onto the network. So we're doing it faster and we're doing it cost effectively. Quite a number of things on the slide there as well about the the A&M system again is at the heart of this, going back to what I was saying about real-time deterministic control. We've got the battery up on the higher left there as well. It was originally a sodium-sulfur battery, but we found out about some of the shortcomings of that technology just in time, and we changed that to lead acid. And the big tank that you can see on the left-hand side with the yellow and red colour, that's a large-scale thermal storage tank, which doesn't exist yet, but we're hopeful that that's going to play its part within this overall system. So this has really been a high-level flyover. So there's a few conclusions I'd like to just draw out. So the Orkney Smart Grid, we've proven the technical and the commercial success from that. We now work with all the rest of the DNOs and to a lesser extent with National Grid, but very detailed workings in a active network management working group with all the DNOs to apply this technology where it's appropriate across the UK. And we also can see that there is currently a revenue gap, as I was saying, for storage, but that shouldn't be taken as being a showstopper. And we believe that it should be viable to link local demand with renewable generation, and we're going to try and prove that up in the Shetland Isles. There's a wealth of information on our website there, which hopefully you get time to follow the hyperlink at some point. The other hyperlink there is the Electricity Networks Association, which is the trade association that all the UK utilities play their part. And there's a Smarter Network portal which you can get lost in, and there's again a wealth of information, a whole range of projects from all the utilities. Last year, the Low Carbon Network Fund Conference, where we hosted it in Aberdeen. This this year is going to be hosted by Scottish Power Energy Networks down in Liverpool at the end of November. If you're able to make the trip down to Liverpool, it's a very intensive few days. It's a little bit like the All Energy Show, if MD or Conference of MD's been to that. There's a mix of suppliers, and again there's a lot of detailed information, and it's a very intensive immersion into what's happening in this area of smart grid technology. So hopefully you'll take up the opportunity.